Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel. So today we're going to be working on episode 6 on the applying quotient rule to trigonometric function series. So as you can see in this question, we have f of x is equals to secant x divided by sine x. The first thing you have to do is whenever you're given a function and you want to know what rule you're supposed to apply, you first of all look at the form in which the function takes. In this particular case, we have two sub-functions and the function basically is a fraction. So we have a numerator sub-function and a denominator sub-function, and the two of them combined is a fraction function. And whenever we're supposed to differentiate, or when we are asked to differentiate a function that takes the form of a fraction, we have to apply something called the quotient rule. So we're going to apply the quotient rule in order for us to differentiate this function. Before we go ahead and apply, let us determine what f of x is and what g of x is. From looking at this, we can see f of x right here is equals to secant x, okay? And then g of x here equals to sine x. So f of x equals secant x and g of x equals sine x. Now that we already have this, we have to now go to the next process, which is applying the quotient rule to it. So wherever there's f of x here, we're going to put secant x. Wherever there's g of x in our quotient rule equation, we're going to put sine x. So go ahead and say d dx of secant x divided by sine x is the same thing as the derivative of the numerator subfunction f of x, which in this case is secant x, multiplied by the denominator subfunction, which is g of x, in this case sine x, minus the derivative of the denominator subfunction g of x, which in this case is sine x. So d dx of sine x, and we'll multiply that by f of x, which is the numerator subfunction, multiplied by secant x. All of that information divided by the squared of the denominator subfunction, all of that divided by sine x all squared. So that's that. And then you have d dx of secant x. So we go here. What is the derivative of secant x? So the thing you have to know is, like, if you're new to this channel, or this is basically your first video that you're watching on my channel, you don't know this, but if you've been watching my channel consistently, anytime I have a topic that has like a specific way questions are asked, for example, when I had to do limit laws in calculus, right? I had the limit law page for the formulas, or pages for the formulas, as well as now that I'm doing trig functions, I always have a page dedicated to trig notes. So if you're new to this channel, I would advise you to please pause the video and write this down. All of this information down will be useful to you. Okay, so on the left side of this equation, we have the trig expression. Sorry, not of this equation. On the left side of this page, with everything written in blue, so sine x equals to 1 over cosecant x up until cotangent x equals to 1 over tangent x, right? All of that information is what we call trig expression. And trig expression just involves how one trigonometric function relates to another trigonometric function. For example, here, sine x relates to cosecant x in terms of reciprocality, just like cosine x relates to secant x in terms of reciprocality, as well as cotangent x relates to tangent x, or tangent x relates to cotangent x in terms of reciprocality, and tangent x also relates to sine over cosine. So that's basically the first part of the trig notes, the left hand side, everything written blue. On the right hand side, we have something called trig identities. Trig identities are how one trigonometric function that is squared relates to another trigonometric function that is squared, right? So you can see this equation where sine squared x relates to cosine squared x in this equation, just like cotangent squared x relates to cosecant squared x in this equation, and tangent squared x relates to secant squared x in this equation. So those are trig identities. And everything else that is written in red marker is what you call trig derivatives. So they are just basically the derivatives of trig functions, and that's really it, the derivative of trig functions. So these are trig derivatives. So in our immediate question, we're asked to find the derivative of secant x. So we're going to go to the part of the trig nodes that have derivatives. So the derivative of secant x, okay, this is sine, this is cosine, this is sine. Oh, secant. We have secant, and the derivative of secant x is what? Secant x tan x. So we're gonna put secant x tan x multiplied by this right here, which is sine x, right? Minus, what's the derivative of sine? Go back here. The derivative of sine is cosine. So we're going to put cosine here, right? Minus cosine x multiplied by, what is the derivative of secant? The secant here. Sorry, not what is the derivative. Secant is just chilling here, so it just drops down. We already did the derivative of secant at this point. So here we're just doing the derivative of the sine, and then we just multiply it by secant x, not the derivative of secant. That was a mistake. Multiply by secant, and multiply by secant just involves us bringing down secant to the denominator. So all of that information divided by the square root of sine x. So sine x all squared. So that's basically what we have. So now let's go on to multiply through and see if there is something we can do to simplify our work. So one thing you need to know is whenever you're dealing with trig functions, you're gonna have situations where during your solution, or even sometimes your answer choices might be quite complicated. And the one thing you need to know in math is that anytime you have your work complicated, that's the whole point of math, to solve something and to get you the most simplified answer possible. That's like the best way to be able to do math. And not that this answer is not correct. Secant x, tan x, sine x minus cosine x, secant x divided by sine. That's good. That's just a lot of work. That's a lot of information. And because we're dealing with trig and we have our trig notes, we can go ahead to simplify this question. So I'm going to rewrite this one on the next page, and then we're going to go ahead and simplify. Okay. So we have secant x, tan x, sine x, minus cosine x, secant x, right? All of that information divided by sine squared x. Just so you know, sine squared x is the same thing as sine x all squared. Just like cosine squared x is the same thing as cosine x squared. Just like cosecant cubed x, right, is the same thing as cosecant x cubed. So very important for you to know that. Very, very important. So yeah, that's basically it. And now we're going to go ahead and start the simplification of our work. So now that we have this, what is a way that we can try to simplify this work, right? Well, one thing we can do is to make every single thing that we have here, every single thing, we can make sure to turn it into cosine x and sine x. That's a simple way of simplifying, since many times people are always used to seeing sine x, cosine x, and sometimes even tangent x. A good way for you to work on this problem is to simplify this entire thing, right? This whole thing, the numerator and the denominator. We're going to try and simplify in terms of sine x, and then we can go from there. So what is secant x in terms of sine or cosine, or both, depending on how the question? Well, secant x, we have secant x here in the red box, and secant x is the same thing as 1 over cosine x. So we can put a 1 over cosine x here. What is tan in terms of sine and cosine? let's go back there. We have tangent x same as 1 over cotangent, not what we're looking for. We have tan equals sine over cosine. So we can put a sine over cosine here multiplied by sine x over cosine x. And then we have sine, so we're just going to leave sine here, sine x, right? So minus cosine x, we're just going to leave that. I'm going to put everything on the other side in bracket just so we can be careful. What is secant x? What else can we represent secant x to be in terms of sine and cosine? Well, secant x can be represented as 1 over cosine x. So multiplied by 1 over cosine of x. All of that information divided by sine squared of x. So yeah, basically now what can we do going forward? Well, what we can do is to try to simplify our work. The whole point of doing it in the first place, we can see cosine x here, cosine x will cancel. Here we cannot cancel anything because on the numerator we have sine x multiplied by sine x. On the denominator we have cosine x multiplied by cosine x. So what we're just going to do is to multiply through. So we end up with sine x, right? And another sine x. So sine x squared divided by, we have cosine x here and another cosine x here. And we have cosine x. Since there are two of them multiplied by each other, we put a squared minus this one cancel this one, so we can just put 1. All of that information divided by sine squared of x. So, or sine x all squared. So one thing we can do is to split the fraction. So we end up with sine. We end up with sine squared x, okay, divided by cosine x squared x, right? So we have this information here. We're going to divide it by this since we're trying to split the fraction. So divided by, make the color of the markers consistent, divided by sine squared x minus 1 divided by sine squared x, right? So we can go ahead. So sine squared x divided by cosine squared x. Well, we can do our math that we learned since middle school. So sine squared x divided by cosine squared x, squared x. Now that all of that information divided by sine x. Well, one way we can do it, like we've been taught in middle school, just like we have 3 over 7 divided by, say, 3, right? We can end up saying 3 over 7 multiplied by the reciprocal of 3, right? Reciprocal of 3, which is the same thing as 1 over 3. So so we end up with 1 over 7. Or we can do the long process of saying 3 over 7 divided by 3, right? Equals to 3 over 7 multiplied by 1 over 3. Same thing. We can do it. This two things mean the exact same thing. I'm just showing you what we're going to do in the next page, but with simpler numbers so that you're not confused as to what happened. So that's it. So we'll come back here. Sine squared x divided by cosine squared x divided by sine squared x is the same thing as saying multiplied by the reciprocal of sine squared x. Remember middle school math. Minus 1 over sine squared x. So what can we do here? Gosh, thank God we can easily cancel out. So what we actually end up with is this. We end up with 1 over cosine squared x minus 1 over sine squared x. Now, I would like to ask you, looking at this work right here in this blue box that we just solved for, and then looking at this one here, which was our answer immediately applied the quotient rule. Please look at the top of the page, this one here and this one here. Which one would you say is the easier to understand when you just look at it? Which one would you say is less complicated? Of course, this one is going to be less complicated. That's the beauty of math and the beauty of simplification in math. And and that's the reason why I have the trig notes at the beginning of every single one of my tutoring sessions, to be able to make sure that you're doing the work as best you can in the best way possible, so that you're not in any way, shape, or form confused, right? You're not confused because it's like, dang, this is a lot of information here, and you start getting stressed out for nothing, when you can just simply use the trig notes to be able to break down your work, which is what we've done so far. So 1 over cosine square x minus 1 over sine square x is a very good answer, as well as in what we had up top. Only difference is one is more simplified than the other, right? So this is a good answer. But guess what? We can even go ahead and simplify further. So we have 1 over cosine squared x minus 1 over sine squared x. So what are we going to do? Well, what we can do is we can go back to our trig notes and then look for a way for us to work with it. Well, 1 over cosine x here is the same thing as secant x. So 1 over cosine squared x is going to be the same thing as secant squared x, right? Because 1 over cosine x, if that equals secant x, and this time around we have 2 of it, and we have 1 over cosine x, right, multiplied by 1 over cosine x is the same thing as secant x multiplied by secant x. Hence why we have secant squared x. So I just want to show you guys the math as to how we got there. Or if your math is your mathematics skills are pretty good, you can, like some of these steps I'm doing, you can easily skip them. But I want to make sure that everyone that is watching the video is on the same track. So the secant squared x minus, what is 1 over sine x again? Or we see that 1 over sine x here is the same thing as cosecant x. And this time around we have 1 over sine squared x. So therefore what we have is cosecant squared of x. So therefore our final answer is going to be this. Now if you compare this answer to this answer to this up top, when we first apply the quotient rule, you can see that the easiest and the simplest and the most well simplified is this one. So basically this is the end of the video. I know usually at the end of my videos I teach you guys a shortcut method. Unfortunately we can do a shortcut method in this because of the fact that whenever I apply this shortcut method, what I do is I like to simplify the function first and then apply the quotient rule. But in this case, trying to simplify this is just going to make it a little bit more complicated. So it might just be best to just go straight and do the quotient rule and do enough practice so that you're not stressed out and you're not too dependent on the shortcut method. Because when I had the product rule series, the fact that it worked for majority of the problems, we could easily do the shortcut method. We can't really do it in all of the questions in the quotient rule. We just have some questions we can and some questions we just cannot. And this is one of those questions because secant x is the same thing as 1 over cosine x. That divided by sine x, so multiplied by 1 over sine x. So this is what we end up with. We end up with 1 over cosine x sine x. And therefore when we try to differentiate this, it's not going to make our work easier in comparison to just going ahead and differentiating this. Hence, no shortcut method. I hope this video was helpful to you guys and I wish you all the very best. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.